In this episode, we're setting up dynamic fire decals that automatically generate based on our flamethrower ability. And they have a completely different effect depending on the physical material that they're interacting with. Let's get to it. Hey guys, welcome to today's episode, and just like 2 episodes ago with the flamethrower episode, this is going to have a lot of new content in today's episode. It is packed with new stuff we haven't done before. So we're going to set up these burn decals to trigger based on the collision of the fire effect, based on the collision of the flame and whatever it's hitting. But the decals aren't static, meaning based on the number of hits at a certain location, that decal, if there is a decal at that location, is going to intensify. It's going to darken over time. And also based on collision, we're going to get the physical material of whatever we're hitting. And based on that physical material, like is it wood, is it rock? So we need to figure out, okay, is this effect going to ember? Are we going to have kind of a glowing effect as that thing is like close to catching on fire? We're not going to make anything catch on fire this episode, but not to spoil things, but further down the series, it's going to happen. But then realistically, it's not enough to just make a material ember and sparkle a little bit, right? So as the fire hits the material, if there's a decal already there, then it should intensify the effect. It should darken and the embers should grow brighter, right? But then as the fire kind of passes over it and it's left to cool down, realistically, we want those embers to fade over time. And so you're going to see how we apply that with what's called a dynamic material instance. And so because this effect is going to vary significantly based on the physical material that's being hit, I strongly recommend you familiarize yourself, if you haven't done so already, with line traces and physical materials. And if you want to check that out in this series, we first cover those in episode 19 on footstep effects. So 3 episodes ago in episode 26, we began talking in earnest about gameplay abilities and how we're conceptualizing those gameplay abilities. And at first, we were working in the top right quadrant and the bottom left-hand quadrant for our abilities. And this is the first episode where really we're starting to affect the environment. And it's really a pretty basic thing, decals, right? It's just applying a material on top of an existing material. But even though decals are kind of a subtle effect, I feel like it makes a big difference to making the game really feel alive. Like everything you do in the game should be responsive in some way, shape, or form, because we want the player to get that immersion, get that sense of like the world and them, they're closely connected. And obviously we're going to do a ton more with fire, but this is the logical first step. So there's just a couple of assets required for this episode. Just a single material that you can download off of Quixel Bridge by copying and pasting the code on the screen. You can also find these in the spreadsheet linked in the description below. And we also need one free content pack from the Unreal Engine Marketplace, Infinity Blade Firelance. And this content pack is about 1 gigabyte, and you could just get the 2 texture files that you see here in this document. But I actually recommend you get the entire pack because there are certain things in this pack that we're going to use in future episodes. Here are the key concepts for this episode. We're doing a ton with materials, we're doing a ton with blueprints, but also this is all going to start in Niagara from our flamethrower ability. So let's get to it. All right, so we're going to start with the simplest possible setup by adding a decal for every single fire hit. And that's going to have some significant performance implications right off the bat. But over the course of the episode, we're going to continuously make improvements to the effect till we get the optimized effect that you saw at the start. So the setup is really divided into 3 parts. So we have the collision itself, and that starts with Niagara. And then we have the material. So how is the material actually going to change over time? And lastly, we have the decal actor blueprint that's going to pull everything together. So let's start with Niagara, where we're going to export particle data, the collision data, from Niagara into Blueprint. So this, if you've been following along in this series, we're going to go to Content Drawer under Niagara and under our Gameplay Abilities, Fire, under our Flamethrower, and we're going to open up our NS Fire Flamethrower system. And before we make any updates to the Niagara system, I always like duplicating it just to make sure we got a backup. So I'm going to right click here and we're going to duplicate, and at the very end, I'm just going to call it backup. And now in our Niagara system, to initiate communication back to the blueprint from which the Niagara system spawns, we have to create a new user exposed parameter, and it's of type object. So I'm going to hit plus here, and then under make new object, it's of type object. And I'm going to title this BP communication. Now I did a lot of experimenting with this effect, and it works just fine if we set up only one emitter to communicate back to Blueprint, because you got to think about this in terms of performance. If every single particle is sending collision data back, and we have like 200 particles a second, that's a lot of data that's being sent. And by using just one emitter, and this emitter is actually 1/5 of our second emitter, then we can only send a portion of the data. And I think we can get the same effect over time. It's going to be enough particles that the effect will blend seamlessly, and you'll see how this comes together. So under particle update here, we're going to hit plus and we're going to say export particle data to Blueprint. And that's how we're sending the data from this emitter. And make sure it's the very last thing that executes in the stack under particle update, because we want to make sure collision happens before this happens. And so now the first thing that export particle data to Blueprint is asking is, what is the condition by which this data is going to be exported to Blueprint? So the condition that we're using is under particle attributes, this Boolean here, has collided. If the particle has collided, we want to send that data. So I'm going to drag that over into the condition to export right here. There's a couple other things I got to change here. So under GPU allocation, I've got to change this to per particle. And then under the callback handler, I just select the user parameter that we created just a second ago, so BP communication. Now these 3 lines right here, these are the data points that we're going to send from Niagara back to our blueprint. And the first one here is the most important, particle's position. So where was the particle when it actually collided? And these 2 parameters right here, we're going to use them a little bit later in the episode to send data, but let's keep them blank for now. And what we're going to use them for is when the fire effect actually hits, we want to know how intense the fire actually is. And so what I mean by that is if the fire is hitting from like 10 meters away, it's not going to apply nearly as intense, nearly as dark a decal as if the fire is hitting really up close. And so we're going to send data from Niagara in terms of how old the fire is or how intense it is in order to apply the appropriate intensity of effect. But here's the other thing that I want to do for each of the 3 emitters here. And this is more of an optimization from the effect itself 2 episodes ago, so you can skip over this. But what we're going to do is we're going to age the particles when they collide. Because when they collide, we don't want them to just like bounce off into space for like an extra half a second. We really want to age the particle so there's some emanation of the fire off of where it's hitting, but not a lot. So what we're going to do for each of the emitters is under particle update here, I'm going to set a parameter directly, set new or existing parameter directly. And the parameter that we're going to set is the particle's age. Now we can't just choose a time frame here because then it's just going to automatically set the particle to that age every single tick, every single particle update. We don't want to do that. So we need to set a custom float by bool. Make custom float from bool. And the bool is going to be under particle attributes that has collided again, because we only want to set this if the particle has collided. Now, if it hasn't collided, then we just want the particle's age to still be the particle's age. So I'm just going to say false float particle's age. But now if the particle has collided, I want to age it a portion closer to its overall lifetime age. And the way we're going to do that is we're going to make this an add float. And what we're going to add is our particle's current age to some fraction of its remaining age relative to its lifetime. And so what I'm going to do here for B is I'm just going to multiply float. And the float's going to be our particle's age. And we need to get a portion of that. So I'm going to divide float. And the portion of it that I want to get is 1/10 of its normalized age. So I can divide by 10 and I can get the normalized age. And the normalized age is between 0 and 1. So if the particle lasts 5 seconds, a 1 normalized age would be the 5 seconds. I know this is weird math, but I tried out a lot of things and it works well in terms of aging the particles. So what we're going to do is copy this and we're going to paste that into each of the other emitters so that all the particles are aged the same way. So I'm going to copy this again, paste it into our 3rd emitter. All right, we are all set for our Niagara system for now, but we're going to need to come back to it. So keep it open. And now we're going to navigate to content drawer and we're going to continue our gameplay abilities that we started in episode 26. And these are under blueprints and then gameplay abilities and our gameplay ability fire. And navigate over to our event graph and the activate primary fire Niagara system event. Now, if you're not following along with this series, you could still follow along with this episode. Basically, you need to go to wherever you're spawning your Niagara system. And then following that, that's where we're going to do what we're doing. So the first step to receiving communication from our Niagara system is we have to set up a reference to that object that we set up as a user parameter. So under components, I'm just going to drag in a reference to our Niagara system, and then I can set Niagara variable by string, and we have to choose the object here and connect this up. And our invariable name here is going to be BP communication, but we have to start with user. So it's user.bp communication. And the user just tells it that it's a user parameter. Now the object, we can drag out a pin here and get a reference to self, because the object that we're connecting this to is our blueprint itself. And then compile and save. The next step is we have to implement an interface from this object. And I know we haven't covered interfaces yet in this series, and this is a weird one. It's kind of an out-of-the-box interface. It's not an interface that we're creating ourselves. So we're not going to cover interfaces in great detail right now, but I'm just going to show you how to set up this one. So up here on the top bar, we have to go to class settings, and then under interfaces here, we have to go to add and search for Niagara and particle callback handler. And once we add that interface here, then we can go to interfaces on the left under Niagara, the receive particle data, and we can right click and say implement event. and it's going to create a brand new event here, event receive particle data. And like I said, this is an out-of-the-box interface and out-of-the-box standard method for receiving certain data from Niagara. And I'm just going to zoom out here, so I'm going to move our deactivate fire ability down below it because we're going to have all of our deactivation stuff below. I'm trying to keep these events in the order in which they'll typically be executed. So we have our activate primary fire Niagara system first, and then down here we have the event receive particle data. So simplest possible test, let's just see if this is working. So let's do a print string and let's just name it fire collided, exclamation points, compile and save, and let's test this out. And make sure to turn on FPS because let's look at our frame rate as we're doing this. Let's see what the collision actually does. So 2. Yeah, so our frame rate's hovering right about 60. That's pretty good. We're getting the fire collided every time a particle hits. And when I cast into the air, no collision, nothing. Cast down there, yep, getting collision. So one thing I'm noticing with the effect, and you'll see that the fire actually dies pretty quickly once it collides, but I'm noticing that it's still pretty bright immediately after the collision. Like even to the end of its lifetime, it's still pretty bright. So we're going to change out that effect a little bit. So let's go back into our Niagara system here. So under color for both emitters, we're just going to adjust the alpha. And the alpha is determining like how bright, how transparent, or how solid that flame effect is at any given point in time. So you see it intensifies pretty quick and then it comes down very slowly. And what I want to do is if I right click, I want to add a key closer to the end and I'm just going to move this down. So at the very end of the effect, it kind of tapers off. It drops very fast and then it tapers off at the very end. And I'm going to do that for this one as well. So I'll right click, it doesn't have to be perfect, add key, and you can play with this as well and see how the effect actually looks after these changes. Save, compile. So now, yeah, so it's a very subtle change, but the fire at the end of its life, it's a little bit more faded, it's not as intense. I think that's more realistic. So the next step is to set up our decal material. So for this, we're going to come to our content drawer, back to content, and we're going to go into our MS presets and into the MS decal material. And we need to make some updates to the MS decal material for this. So anytime you make updates, let's make a duplicate. So we're going to right click, we're going to duplicate, and I'll keep it MS decal material, and I'm going to put fire effect at the very end. And this material is actually going to work differently depending on if it's applied to a flammable or a non-flammable physical material object in the game. But we're going to start with the non-flammable and we'll go from there. So right click on this material and we're going to create a material instance. And at the very end, instant, we're going to call it non-flammable. One word. Now we'll go into the material instance, and we got to make some updates to the albedo, the normal, and the DRO. So the albedo, we're just going to make it black. If you just search for black, and we'll choose the MS presets, MS textures. And I'm going to select the normal as well, and I'm going to change this to base flatten normal map. Base flatten normal map. Now DRO, I did some exploration on this and I don't fully understand it. I think it stands for displacement, roughness, and opacity or occlusion. Not sure what the O stands for. But this is going to drive the shape of the decal, what we're actually applying on the material. So we need to change that as well. So once you select that, then we're going to search for grayscale. And what this is going to do is it's going to make the effect much more intense in the bright center there and then fade outward. And the albedo, that's going to define the color of the effect. Now, the final step to getting this set up as a basic effect is we need to spawn a decal actor whenever that collision is hit. So let's go back to our gameplay ability fire, and instead of the print string here, I can delete that out. I can spawn actor from class, and then the class that we're going to select is, of course, decal. Now, we're going to end up creating a brand new blueprint class for decals by the end of this episode to accommodate the behavior that we need. But just for this first example, let's select decal actor here. And so now we need to tell our decal where to spawn, and that's the spawn transform right here. And so what I'm going to do is I'm going to split this up into the location, rotation, and scale. I'm going to move this out. And we have our data right here. And anytime you see a square like this, that means the data is being sent as an array. And anytime you get an array, it's really a collection of objects. And the reason it's a collection in this case is because our Niagara system has more than one particle. So we could have 20 particles all sending data in the same tick, and they all come in over an array. And anytime we need to get data from an array, we got to do it via a loop. So we got to do a for each loop, because it loops through the entire array, and then for everything in the array, then it does something, whatever the loop body is. And you can also use an execution pin to tell it what to do once the array loop completes. So I'm going to connect this up, and then our array element from this I'm going to break, and I'm going to break our particle data. And we have our position here, and then I can connect up our loop body here. So we're telling it, okay, here's our position of the hit, and spawn a decal actor at that location. And now let's compile and save, and we'll test this out. But before I test it out, I'm just going to move over to the very center of the map because it's not going to work on foliage to start, and I'll explain why. But let's just move it out right into this block that I've kept there since episode 3, really the first episode of our series. All right, here we go. Well, that's not so good. So the reason this is occurring is because a separate decal is being spawned every single hit. And we never told our decal actor what material to use, and so it's using this out-of-the-box, crazy, emissive material. So let's create a new decal actor where we can specify the details that we actually need to make this decal work properly. So let's navigate to our content drawer and then back to content. Under blueprints, we'll create a new folder called Decals. And here we're going to right click and create a brand new blueprint class. And our parent class is going to be decal. So decal actor and select. And this is going to be Fire Decal _BP. And we open that up. And now the first thing is let's define a variable for the material of the decal. So under variables, I'll hit plus sign here, and this is going to be our non-flammable material. So I'll title this decal material non-flammable. Now the type, this is kind of strange. So it has to be a material interface and an object reference, and then compile and save. And when I do that, then I can define the default material for the decal. And this is going to be our MS decal material fire effect here, the non-flammable one. So now what we've done is we've set a variable for the decal material, but we haven't actually assigned that to the decal. And so for that, we're going to navigate over to the construction script here. And from the construction script, I'll drag out a pin and I'll set decal material, decal. And that's referencing our primary decal right here. And so our new decal material, that's exactly why we created this variable. So we can drag in a reference, and we're just going to connect that right up here. But now here's the thing. So with this flamethrower ability, or really any fire ability we have in our game, we're going to have a lot of these decals throughout the world. And we want to make sure that the material for each of the individual decals can vary independently of all the others, be lighter or darker compared to all the rest. And the way we're going to do that is by creating something called a dynamic material instance. And each of these individual decals will have a separate material instance. And so the way we're going to do that is we can drag out a reference to our decal, and we can create a dynamic material instance. And then we can connect this up. But then we want to be able to change these decals over time, right? So we want them to be able to get darker if the fire is hitting them repeatedly, or if we have embers on the decal, and you'll see that by the end of the episode, we want those to be able to lighten over time. And so to do that, I got to make sure I have a reference to this dynamic material instance. So we'll promote it to a variable, and I'll right click over here and I'll just call it decal material instance. And for this one, I'm going to make it instance editable, but we don't actually need to expose it on spawn. The last thing I'm going to do on this blueprint, because the default decal is pretty large, I'm going to select the decal, and we're going to resize it here on the right-hand side. So I'm just going to expand that, and I'm going to make it 32 by 128 by 128. So not nearly as deep a decal, and about half the size, half the width, half the length, really a quarter of the size. Lastly, compile and save. And so now we got the basics of this decal set up. So let's drag it into the world, and we'll see how it works. Yeah, so we see the actual burn effect right there. That's looking good. So now let's set it up to be spawned based on our gameplay ability Fire. So back in our gameplay ability Fire, so I'm going to switch this to instead be our new decal. So I can search for Fire Decal BP. I'll select that. And we're already sending the collision position, and that's going to be the location at which the decal spawns. If you remember, we set that up in the export particle data to blueprint in Niagara. So that's this particle's position. Actually, that's the default data that gets sent. And we're going to need to send this second vector here now, but not as 0, 0, 0. And the reason we need to send it is because we got to get the normal of whatever object the fire is colliding against. Because the decal, it always has to be applied against the object according to the right angle, right? And here's an example when the decal is not appropriately applied. So if I switch the rotation here to 0, so then our decal is long ways, and that's not going to work. So we always need to get the rotation of the object that we're hitting so that we can apply the decal directly to it. So back in Niagara, if we scroll down past particle attributes, we got to go down to module outputs. And I'm going to move this a little bit over so you can see these. So we have these two outputs for output module 1 collision 1 normal and module collision 2 normal. I'm actually not sure what the difference between these is, but I just set up module collision 1 normal as the data that we passed in this vector, and it worked just fine for me. So that's what we're going to do. So basically, we're getting the normal of whatever we're colliding against, and then we're going to pass that as a vector here. So I'll save our Niagara system, and that vector is going to be passed back in the blueprint via the velocity node right here. And so this is going to determine what the rotation of the fire decal is going to be. But we can't just connect it up here. And the way we have to do this is we have to make a rotator from the z-axis. And this is a little bit difficult for me to understand, but I think of the z-axis as sort of the height data. You know, it's basically the normal map of the object. And so based on that angle, that's how we can apply the decal rotation. All right, let's compile and save, and we'll test this out. But make sure you've got FPS turned on, show FPS, because you're going to see a crazy FPS drop as we do this. Here we go. So we got our decals, but they're a little dark, they're a little shiny, and our FPS is already down to 30 in about 2 seconds of spawning decals. And here's another interesting thing. So I cast it on a rock. So I'm getting the decals, but my rocks are not, but they are showing up here. So how do we solve all these issues? Let's take care of the rock foliage first, how to make sure that foliage will get our decals, and then we'll talk about the rest. So to address the fact that the decals are not showing up on any foliage, so we're going to go into foliage mode, and then from foliage mode, I'm going to go ahead and select all of our foliage, but you can select on whatever types of foliage on which you want to apply the decals. Now, in order for this to work, there has to be some sort of collision to collide with the foliage, and it's actually not going to work for any of my plant foliage because I don't have collision turned on for any of them. But I have something specifically in mind for plant foliage in the future and how fire is going to interact with that, because obviously that's flammable. And so we'll cross that bridge a little bit later in this series. But for any foliage that already has collision, like rocks, this is going to work just fine. So what we need to do is after we select all of these, we scroll down. And if you keep going down under Instance Settings and then under Advanced here, we need to select Receives Decals. And once you do that, just hit Save. We'll navigate back to our regular mode and try this again. All right, I got a nice rock here. There we go. But now let's address the fact that the decals are showing up on the player inappropriately. So for that, we've got to go to our content drawer, back to content. I'm going to navigate into my third-person character blueprint. And under the details panel for the mesh, if I search for decals, we have this receives decals checkmark, and I can just uncheck that. Now, depending on the type of game you're making, you might want to leave this on. So you might say, Neil, I've got to have blood on my characters, or any character for that matter. We can't just disable decals completely. And that's fair. So decals are one of the main ways that you can alter your character if a wound occurs or something else on the character. But I think I'm going to handle this in my game a little bit differently. And I found this really good post by Tom Lumen, and here's the website. I'll put it in the description below. But basically, he goes over some of the ways that blood and other effects can be done on characters. And you have this problem with decals frequently on a moving character where the decal is inevitably attached to a part of the character's body, but that part can turn and squirm and move in weird ways, and then the decal doesn't accurately reflect how the character is moving. And so his solution is to use what's called a sphere mask, which, to be honest, I don't have that much experience with, but that's the route I'm probably going to go down. And so we'll cross that bridge when we get there. And also, one of my pet peeves about decals is, at least in blueprints, there doesn't seem to be a way of saying, okay, for this type of decal, only apply to these types of actors. Like, I haven't seen a good demonstration of being able to do it by tag or anything like that. But if you have a good way, if you figure this out, please post in the comments below. And we'd love to have you in the Discord. We meet every Friday from 6 to 7 p.m. Eastern Standard Time. And here's a link to the Discord, right up there. But for now, we're just going to keep receives decals off, compile, and save. Now let's address the issue where the decals are really shiny. For that one, we've got to go to our child material, and we actually have to go back to the parent. So I'm just going to navigate to the parent right here. So where that shininess is coming from is the specular here. And right now it's set to about 50% shiny. And so I can turn this to 0, and that's going to make it completely opaque, not shiny at all. So let's save this, and then let's test out those two things, the shininess, but also let's test out our character, make sure the decals aren't applied. All right, we've got a really close rock. So that is really, really dark, but at least it's not shiny. So that brings us to our final two problems. One, these decals are getting dark way, way too fast. And then the other problem is our FPS in the top right corner. So what if we could solve both of these problems simultaneously? And what I'm thinking is, whenever a decal gets spawned, well, we have a decal there. So what if we could do some kind of trace where we could identify, okay, before we spawn another decal in that same spot, does a decal already exist? And if it does exist, then just darken it based on the collision. And then if we don't get a hit, if there's no decal there, we'll spawn a new decal, but we'll spawn it at a very, very light opacity. And then we can slowly increase that opacity over time with more and more fire hits. So the first thing we need to do is we need a mechanism to determine whether or not a decal is already at that location. And so for that, we got to set up a collision box on our decal actor. So I can close out of our decal parent material. And I'm going to navigate back to Fire Decal BP. And we're going to add a new component. This is going to be a box collision. Select that. And I'll just call it collision box. And we want to keep the box extent 32 by 32 by 32, because if we go into the viewport here, I'm just going to switch over to decal. So we always want the collision box to be a little bit smaller than the decal, because the decal, you got to remember, it's kind of a circular thing where it's very dark in the middle and then it's less dark on the outside. And we want those to be able to overlap somewhat. And the only way to ensure that they're able to overlap is that it only gets a collision if it hits like directly in the middle. And the implication of that is we are going to have more decals, but we're not going to have so many that it's going to be a drastic performance hit. So now we need some kind of mechanism to determine, okay, when we do a trace, do we actually hit a decal? And in order to ensure that this only hits decals, it doesn't hit anything else on the trace except for decals, the best way I've come up with for handling that is by creating what's called a new trace channel. Because if you remember from previous episodes, usually we trace just by visibility. But in this case, we're going to have a channel that nothing else uses but decals. And so to create a new one, I have to go to Settings and then Project Settings, and I have to search for Trace Channel. And it says you can have up to 18 custom channels, including object and trace channels. And so we're going to create a brand new trace channel. And I'm going to call this decal. And for the default response, so when we create a new collision box on any actor or collision sphere, what is the default response that we want for this trace channel? And the default for most actors in our world, I want this to be ignored because we're only creating this specifically for decals. So I'll hit accept here, and then we got our new trace channel. I can close out of this, and I can navigate back into our actor. And so now if I select our collision box and then I come down on the right-hand side, and I can expand under collision here, I can expand collision presets. And instead of overlap all dynamic, I'm going to select custom. And then we're going to set all of these to ignore except for our new trace channel decal. And that's going to be block. So I'll compile and save. And now let's go back to our gameplay ability Fire because we need to do a line trace to see if we actually hit a decal. So the first thing I'm going to do is I'll break this pin. I'll move this a little bit out, give us some space. And from the loop body, I'll do a line trace by channel. And so first, let's just set up the start and the end. So our start's going to be where our flamethrower begins, which was in our hand socket. And then the end's going to be, well, wherever it hits, right? Wherever that fire actually collides. So in order to get a reference to our hand socket, we first need to get a reference to our third-person character. So that's down here, get third-person character reference, and drag out. And then we need to get a reference to our mesh because that's where the socket actually is. And then from there, we can get socket location. And our socket's going to be titled hand_r socket, and the S is capitalized. So I'm just going to move these two down, create some space over here on the left. That's going to be our start location. Now, one thing I noticed is if we just pass in the position of our Niagara collision, this line trace actually isn't going to hit. And the reason for that is because the Niagara particle actually has width, like it has a certain size, and our collision occurs at the middle of that location. And so it's not necessarily the case that a line is actually going to hit whatever object is there because that width is taking up some of the space in between. So what I'm going to do is I'm actually going to double the length of the trace. Like it's still going to go in the same direction to do the trace, but it's just going to double the length. So I'll move this out a little bit and then I'll get our position of the fire hit and then I'm going to subtract that from where our flame originated. So that's the distance between the fire hit and our hand. But then we can take this distance and we can add this to our position from right here. And so that's going to go through the original position of where the flame hit. It's going to keep going in that general direction. And then our end's going to be from that. Just for now, I'm going to disconnect this, just clean this up a little bit. So I'll move this down here. How's that? A little bit cleaner? So now we'll set our draw debug to for 1 frame just to see if this is hitting. Compile and save. We'll do a quick test. 2. Yeah, so we see the hits right there, right? They're drawing just for a moment and then they stop. So now, instead of using a trace channel visibility, this is where we're going to switch it to our new trace channel, the decal we just set up. And so what I'm going to do is if it returns true, meaning it is a decal, so this is then going to change the decal. And if false, then we're going to spawn the decal. So now let's do this. If false, we'll connect this up here. We got our make rotation from Z, connect that here. Going to take a node for position. We'll connect that up there. Reroute it a little bit. And then if true, we'll just do a print string. We'll say hit decal. And this is a good performance test, right? Because if we're just changing a decal, that's not going to be too performance intensive compared to spawning them over and over and over again. So we'll be able to see how much our performance drops, and we'll be able to see how often we're hitting those decals. So let's give this another whirl. 2. All right, so we see a lot of hits there, right? But look at our performance. So it's actually pretty good. It's still in the 50s and 60s, so it dropped a little bit. but not bad at all. And that's already looking a lot better, right? It doesn't look nearly as intense as it did before. But now is where the fun of this episode really begins, because we're going to get into truly dynamic materials on our decals. So the first thing we're going to do, if we go back to our child material, so MMS Decal Material Fire Effect Instant Non-Flammable, we're going to make the initial opacity of the material a lot less, because that initial hit, it should barely be seen, like a very, very subtle darkening. So we can check off the opacity intensity here, and then instead of 1, it's going to be 0.1. We'll save that. Next, we have to go back into our Niagara system, because we're finally going to set the intensity of that Niagara system to determine the opacity change of our decal. So when I say intensity of the Niagara system, I don't actually mean the intensity here, because that's driving how many particles overall spawn, and that's already going to drive how quickly the opacity changes. But when I say intensity, what I'm really thinking about is how close to the actual source of the fire is the hit taking place. Because you can think of an object example where the object is like 10 feet away. In a flamethrower hitting that object, it's not going to have an effect nearly as intense as if the object is, say, like 2 or 3 feet away. And so I was thinking about how we can convey that intensity, basically how far away that object is that's being hit, so that we can darken it more significantly faster if it's closer. And I came up with what I think is going to be the best way to do it, which is the color, but specifically the alpha of the particles. Because in the alpha here, you see it starts at 0.5 and then it scales up very quickly, and then it goes down slowly over time. And what I was thinking was, could we pass this curve value at any moment in time? Because what it's really measuring is how bright that fire is at any moment in time. And we could pass that value in as the intensity in the export particle data to blueprint. So this float to send here. And this way, if the fire hits when it's all the way at the end of its lifespan, like it's barely having an effect on the object. But if it hits over here, yeah, it's going to have a darkening effect very quickly. And in future episodes, we could apply this the same way for things like damage from the flamethrower, but also things like how quickly an object lights on fire. And so if we go back to export particle data to blueprint, for the float to send here, what I'm going to do is do a drop down, and I'm going to make a float from linear color there. And then the linear color, that's actually going to be under particle attributes. That's going to be the particle's color. I can drag that in here, but I specifically need to get the alpha channel. Now, one thing I noted is that this alpha, it never goes above 1 and it never drops below 0. So even though here on the curve, it does go above 1, from about here to about there, it's going to be in that 1 range, like that full strength range. And to use a baseball analogy, like if you're swinging, you always want to hit the ball in what's called the sweet spot of the bat. Like it's not too far to the end of the bat and it's not too close to the handle. And so I'm thinking about that similarly with the flamethrower. And then there's going to be some player skill involved, right? Like the target that they're trying to hit has to be within a certain range to really get the full effect. So now that we've set that float to send, let's save this. Let's go back to our gameplay ability fire. And then instead of printing hit decal here, I'm just going to drag out a pin and we're going to append. And instead we're going to say hit strength and colon, and that's going to be our first thing that prints. But then our second thing is the hit strength from size here. That's the float variable that we just set inside Niagara. Compile, save, let's test this out. So here's what should happen. On the initial hit, it's going to have a very light opacity decal spawn. And then on the left-hand side of the screen where print strings show up, it should show anywhere from 0 to 1 what that intensity, what that alpha of the particles at the time of collision is. Yeah, so there's our hit strengths there. So you see a lot of 1s. And then if I go up here, if I go a little bit further, yeah, we're not getting a lot of 1s now. Now it's dropping. Let's turn to a different direction. So let's try from very far away, something, or not very far, but reasonably far. So yeah, so now we're not getting any 1s, right? We're getting a lot of low numbers there. And that's perfect, exactly what we want. And so now, how do we change the opacity of our Fire Decal BP that we've already spawned based on the intensity, based on this that we're passing from the Niagara system? So the first thing is I'm going to delete out this, I'm going to delete out this and this. And what I'm going to do is I'm going to break the hit result that we get from this line trace, because we need to get the hit actor. We need to get what we're actually hitting. Now, if we create other types of decals in the future, then it could be other things other than our Fire Decal. But what we're going to do in this case is we're going to cast to Fire Decal BP, because we need to update our Fire Decal that it's hitting at that location. And then just to save some space, I'm going to collapse this. Now the question is, what are we going to do on Fire Decal BP? And so what I want to do here is I'm going to create a function, and that function is actually going to live on the Fire Decal Blueprint. And that function is what's going to get called, and that's what ends up darkening the decal. So let's navigate over to that Fire Decal BP, and we're going to create a brand new function here called darken decal. And so now for this darken decal function, we need to get how much we want to darken the decal. And that's going to be based on the float that we're passing in from the Niagara system. So we need to set up an input here to get that float. So this is going to be our fire intensity, and make sure that this is a float. And then once we've got that on our darken decal there, we can promote it to a local variable. And I'm just going to rename it here. It's going to be local fire intensity. Next, we need to determine what the level of opacity on the decal currently is, because the darkening is going to be based on the current opacity. So to do that, I'm going to drag in a reference to our decal material instance, and we need to get a scalar parameter value. Get scalar parameter value. And that's going to be based on our scalar parameters that are in our child material. So right here, we got opacity intensity. So just like that. So I can name this opacity intensity. And so what we need to do now is we need to add something to this value and set it once again, because it's always going to darken, right? That opacity is always going to go up with the fire hits. But the amount that it darkens is going to be based on our local fire intensity. And I'm going to multiply that by a random range. So a very small value, but it's going to be randomized so that it's kind of a random effect when it hits. So that randomness is going to be 0.001 to 0.002. And then the current opacity intensity is going to be added to that value. The other thing I'm going to do here is I'm going to clamp it to make sure that the opacity never goes beyond 0.5. So 0.5, and then we can get another reference to our decal material instance. And from here, we can set a scalar parameter value. Connect this up, and it's going to be the same as over here, opacity intensity, and connect this up too. So now we can compile and save this, and back in our gameplay ability fire, now we can call that darken decal function. So darken decal, just like that. We got to pass in our fire intensity. So where's that coming from? That's our size here. It's just called size because that's what this interface does by default. So size, we can pass right over here. Just going to add a reroute node right about there. Compile, save. So now we test the darkening. And we see it getting some hits. I see some red squares there, but the issue is it seems very, very inconsistent. And the red squares actually seem to be projected into space, like they don't seem to be on the object, because you see the green going forward. And so what's happening here is we're spawning the Fire Decal BP based on the particle position data that's sent from Niagara. And the problem is when the particle actually collides from Niagara, because the particle has size, it's kind of colliding in midair, and so it's spawning the decal here when it should be on the surface right here. And so I got a pretty simple way of handling this. So we're basically going to do another line trace by channel if this is false, except the new one that we're going to do is going to be a trace channel of visibility. And then when it hits an object, that's when it's going to spawn the decal. Because you got to think of this as a lot more precise, like it's hitting at a precise location relative to the Niagara particle hit, which is when that general particle comes in proximity of an object. So we're going to disconnect this pin here. We're going to drag this down. I'm going to copy the line trace by channel here. I'm going to move this trace channel over to visibility. False is going to connect up here. And the start is going to be the same thing as over here. So we're going to get our socket location, paste that in here, do the same exact start. And we can get rid of both of these because we're not going to need them now that we're doing a far more precise trace. So I'll move this out a little bit, move it down. So we've got to get our position, and just like here, we've got to subtract it from our hand-R socket. So I'm going to subtract, and then I'll connect this up here. And so what this is doing is it's basically getting the vector distance between those 2 points, the hand-R socket and then where it hit. And then we're going to add that position to that difference. So we're adding that, we're getting that difference. We're basically tracing out the particle twice as far. Can add a reroute here. Make sure that this trace channel is set to visibility. Come over here. So if we then get a hit, and we should get a hit because our particles earlier got a hit, that's when we're going to spawn the Fire Decal BP. So I'll connect up the true here. Now from our out hit, we're going to break this, and I'll expand it here, and this is where we're going to get our precise location. And then we can get our normal, we can do the same thing, make rotator from Z, and connect that up to the rotation. And I'll collapse this just to save some space. And then for the transform, I'm just going to do something a little bit interesting here, just vary it up a little bit. So we're going to split the struct pin, and I'm going to do a random float in range for each of these. And what that's going to do is it's going to vary the size of the decal slightly. So not a lot, but enough that it could be ovular instead of being basically a perfect circle every single time. So I'll duplicate this, and we're going to vary that up just for the X and the Y. The Z is the depth, so that's always going to be consistent. So now before we test this, over on the line trace by channel here, I'm going to remove this debug, and we're only going to do this one just to see if it's hitting. So before we test, I made one mistake here. So if you expand this, instead of the normal, we got to connect this to the impact normal. The other thing I'm going to do is I'm going to draw this for duration just so we could see for 5 seconds after the hit. Make sure that line trace looks good. And now let's test. All right, here we go. So 2. Yeah, I see our ground darkening. I'm also checking our frame rate. So it's hovering around 60. That's looking good. Let's try our pillar. Yeah, that's darkening as well. Frame rate's still looking good. So far, so good. So I'm going to go back into our gameplay ability Fire. I'll set our draw debug type to none and compile and save that. And now let's get into the fun stuff. So on the intro, you saw that when we hit a flammable material like grass, then the material could change to have kind of this smoldering effect. And then over time, if no flame hits it, then it could slowly cool and also darken over time. So let's set that up now. So the first thing we got to do is we got to set a Boolean variable on our Fire Decal BP. And this Boolean is going to determine, okay, is the material that we're hitting flammable or not? And should that decal that it's on be a flammable decal or not? So over on variables here, I'll just hit plus and I'll just say flammable, question mark. And it's going to be a Boolean type. But for this, we also need to make it instance editable and exposed on spawn, because based on the physical material that our line trace hits, that's when we're going to set this to be true or false. So now, back in our gameplay ability Fire. This setup is going to be very similar to our episode on footsteps, so if this is confusing with physical materials, I strongly encourage you check that out. I think it's episode 19. So what we've got to do is we got to get the physical material that's being hit. And so you're going to need to set up physical materials in your world if you haven't done that already. But if you have set those up, then we can get our physical material here. And then from the physical material, we can get the surface type. And then from the surface type, we can switch based on the E physical surface, which is just an enumerator. And I'll connect up true here. I'm also going to expand this out. Now what I'm going to do is I'm just going to select none here, and then I'm going to switch right back to Fire Decal BP. And that's going to ensure that we then have our flammable Boolean show up here exposed. So by default, I'm going to connect this up here. It's not going to be flammable. And the same goes for dirt. Dirt is not flammable. Stone is not flammable. Wet dirt is not flammable. Water, certainly not flammable, but we don't even want a decal spawning on water. So water, I'm going to keep entirely blank. But then I can make a copy of this right below it. And this is what's going to be used for flammable materials. So forest floor, yep. Grass, yep. And wood, yep. Flammable checked. And then we got to assign all of this stuff. So we can get our location, assign it here. We can get our make rotator from Z, assign that there. Random float and range, connect that up to the X, and this one up to the Y. Just going to drag these 3 down, make it a little bit less disorganized. That looks good. Now there's 2 other pieces to this setup. So the first is we have to set up our material to support that smoldering effect. And we're going to go into our parent material and do that. And then once we do that, then we can hook up that new material setup to our Fire Decal BP actor. So let's compile and save this. We'll go into our child material. We can go into our parent material here. Now the entire smoldering effect we're going to tie into the emissive color here. We haven't done anything with emissive materials yet, but basically it's exactly what it sounds like. It's a material that gives off light, and that's what we need for a material that looks like it's smoldering. And we're going to create this effect by combining 2 textures together. There's going to be our primary texture, which is like the actual burnt material. And then there's this lava material that's going to have a panner node, and it's going to have dots that particularly shine through our original material. The dots are going to look like embers burning on that material. So let's come down to the bottom of the material here. And we got to search for the 2 textures that I called out at the very beginning of this episode from the Firelands pack. So if we go back to content, Infinity Blade Firelands, and the first one is T_fire_lava. And this is what's actually going to shine through. This is what's going to give it that fiery effect. So I'll drag this in. And the second one, if I go back to the content drawer, second one is T_fire_burnt_grass. Yeah, this one right here. Now we also need to create a new scalar parameter called fire intensity. So scalar parameter, I'm going to call this fire space intensity. And by default, this is going to be set to 0, so no ember effect. But making it a scalar parameter is what allows us to change it over time with that dynamic material instance. And I'll move this right above and drag it down a little bit further. And now we need to connect these 3 up. So the first thing we need is something called a panner node. And this is interesting. So a panner node, it basically scrolls the texture over time. And because different parts of the lava texture here are darker, some parts are more fiery, then it's going to give the effect that I was talking about where the embers kind of dim and then they get brighter again. It's going to look really neat. So we'll connect this up here to UVs. And so the panner, we have to give it a movement speed. So 0.01 and 0.02. It's going to be very slow. Now we need to multiply these 2 texture samples. That's going to blend them together. So we'll do a multiply node and then connect up both RGBs. And then for our fire intensity, I had to play with this to get the right effect, but the right multiplier that I found was an effect of about 1000. And then we have to multiply both of these together. And by the way, if you wanted it to really smolder, you could try cranking this up to something like 10,000, but I don't necessarily recommend it. And then for this whole thing, I got to connect this multiply node all the way up to emissive color. Last thing I'm going to do is comment all of this. So see, smoldering fire effect. And then save our material. And with this fire intensity set to 0, by default it's off, so it's going to have no effect whatsoever on the material. So now we've got to create a second child material to take advantage of this new smoldering fire effect, and that's going to be our flammable material that we use on our Fire Decal Blueprint. So if we navigate back to our content drawer, and I'm just going to exit out of this, and we have to go back into MS presets and then our MS Decal material. And I can right click on the non-flammable material instance that we already created, and I can duplicate that. And this is going to be flammable instead of non-flammable. Just delete out the non. And I'll go into that. So just a couple of things that we're going to update for this flammable material on the material instance here. So we're going to update the albedo and then also the normal map. And so to do that, we're going to use the charcoal that we got from Quixel Bridge. I also mentioned that at the beginning of the episode. So if we go to our content drawer, we go back to content and then megascans, decals, and this charcoal pile. Now, if you see this VT in the bottom right-hand corner of these textures, we're going to need to disable that to get them working here. So we'll just double click here. And then if we go under advanced, under texture, I need to uncheck the virtual texture streaming here. Save. And we'll do that also for the normal, this one. Virtual texture streaming, unchecked, save. So now the VT should be gone from both of those, and I can drag that into the albedo just like that, and drag this one into the normal just like that. The one last thing I'm going to do here for this child instance is I'm going to change the opacity intensity to a default of 0.25. And the reason for that is that our texture here is not quite as dark as what's on our non-flammable material that we first created. So now we got our new child material set up. We can save this. And the last piece is we just got to set up our Fire Decal BP. So the first thing is let's navigate over to our construction script here and let's make some space, because the first thing is we need to assess whether or not this is going to be a flammable material. And if it is flammable, we're going to use the brand new child material that we just created. If it's not flammable, then we're going to use this one. So we'll move this down here. And then what we're going to do is we can duplicate our decal material not flammable, say duplicate, and I'll call this one decal material flammable. Compile and save, and then for this one, I'm just going to set it to be the flammable material. And so we can copy all this, we could paste it up here, we define the true branch, except this one, I'm going to delete out decal material not flammable, and we'll just move it to our decal material flammable, and connect that up. And so now we're setting what the material is for the decal based on whether or not when we spawn it, flammable was set to true. It's using the flammable material if it was set to true, not flammable material if it was not. And regardless, it's going to create a dynamic material instance where we can then update all the scalar parameters that are on the material. And so now the last piece that we want to do before we actually test this out, let's navigate over to our darken decal. So the decal is going to darken regardless of whether or not it's on a flammable material, right? But what is going to be different, depending on if it's a flammable material or not, is whether or not it smolders, whether or not we get those embers created in the material. And so at the end of this, let's get a reference to flammable, and we'll connect that up to a branch, connect this up. And so now if flammable is false, we don't want to adjust the fire intensity at all, right? Because it's not going to smolder. But if flammable is true, that's when we're going to adjust it. So the first thing I need to get a reference to our decal material instance. From there, I can get a scalar parameter value, and this one's going to be fire intensity, because we always want to change this or scale it up or scale it down based on whatever the fire intensity is currently. And connect up true. I'll add a reroute just for aesthetics here. So under our local variables, we already have our local fire intensity, so I can drag in a pin there. And based on this, that's going to add to this fire intensity on our material. But in testing this out, we need to adjust it very slowly based on each hit. So I'm going to multiply this by a tiny, tiny number. I think it's 5 zeros. Yeah, so 0.000005 zeros and then a 1. Basically the smallest fraction that I could set. And then we're going to add that to our existing fire intensity. So we'll connect this up. And the last thing is I'm going to clamp this, because if it gets above 1, you'll see some crazy stuff. But the other thing I'm going to do is I'm going to clamp it at the minimum value of that 0.000001. And you'll see why I do that in just a little bit. And so now we'll get another reference to our decal material instance, and we'll set scalar parameter. Connect this up. Copy the fire intensity over here, and last but not least, connect up our clamp. Compile, save. We're going to test this out in 2 places. We want to test it out on grass first, and then over to gravel. All right, we're out in the field with lovely grass, and let's see what happens. Gradually starts to ember with time. The embers intensify very, very slowly with time. They get brighter, they get brighter, they get brighter. So far, so good. But the only issue with this now is that the embers, they never fade, they never change. And thinking about this more, realistically, the embers would slowly fade with time, but as they're fading, the area around it would still grow darker and darker because technically it's still burning. So why don't we set up an ember fade function that takes care of both of those things? So first, let's do a really quick test on rocks and gravel. So they do darken, but I don't see any embers, and that's exactly what you would hope for with a rock. And our gravel? Yep, same effect. So far, so good. So back in our Fire Decal BP, let's create a brand new function, and we're going to call this one Fade Embers. And so the way I'm envisioning this function to work is it's going to get called 10 times a second, but it's only going to get called if there are embers still smoldering. And every time it gets called, it's going to check, okay, is that fire intensity greater than 0.0001? And if it is greater than that, then it's going to call again as soon as it reduces the smoldering effect. And that's exactly why under darken decal here, I clamped it at 0.00001. I think I said the right number of zeros there. Okay, back to fade embers. So the first thing is we got to get a reference to our decal material instance. We got to get our scalar parameter value, and the value we're getting is our fire intensity. And if our fire intensity is greater than 0.0001, 3 zeros, then it's going to fade the embers and execute the function again. I'll connect this up here, move this down to be parallel. Okay, so we need another reference to that scalar parameter value if it is true. Connect that up there. And what I'm going to do is I'm going to multiply this value by 0.995. So basically the new fire intensity will be 99.5% as strong as it was. So even though it's called 10 times a second, fading very slowly. And then I'll clamp this, as always, between 0 and 1. And then I'll get another reference to our decal material instance, and this time we'll set a scalar parameter value. And it's going to be the same thing, fire intensity. And we'll hook that right up to the clamp. Connect this up. But you heard me say earlier that as it's burning, I still want to make the decal darker as well, right? So if I go back to our darken decal, so we've clamped that at 50%, so it only goes to 50% opacity. So why don't we clamp the actual burnable material as it's burning? We could clamp that at a higher value, something like 70% opacity. And that way the burnable materials can actually grow darker than non-burnable materials. So let's navigate back to fade embers, and let's copy this entire segment, because we're going to paste that again over here. And all we're going to do is we're going to change this to opacity intensity. And we're also going to change it on the second parameter here. And instead of diminishing the opacity, we have to increase it. So it's going to be multiplied by 1.0001. And the clamp is going to be a maximum of 0.7. So I'm going to comment both of these. So this, I'm going to do a comment, and this one is going to be set fire intensity to be 99.5% of previous fire intensity. And then I'll comment this one as well, and I'll say set opacity to be 0.01% greater than previous opacity up to a maximum of 70. So the embers we're going to be able to see with time, but the opacity, that's not going to be all that obvious. So let's do a print string here. And just so we can actually see what the opacity number is going to be. So I'm going to do an append, and I'll say opacity, and I'll connect that up to the clamp value here because we want to make sure that our clamp is correct, that it's clamped to kind of the right threshold, and also that it's increasing at the right rate. So we don't want it to get to 0.7 right away, and we don't want it to be too slow either. And the last thing we're going to do is we're going to call this function every 0.1 seconds, but we're only calling it at the end of this string. So if this evaluates to false, then it doesn't call the function again. So how do we call this function every 0.1 seconds? So we're going to use a new feature we haven't used yet this series, and I love this feature. It's called set timer by function. So we could drag out a pin. We could do set timer by function name. And our function is what? So it's fade embers. So we can put that in here, fade embers. I think it's case sensitive, so make sure you get that right. No spaces. And the time is 0.1. So it waits 0.1 seconds after this is hit, and then it calls that function again. We don't need to loop it, right? Because technically it's already looping. So it's just going to call the function. It'll go through this entire string, then it'll call the function again. The key is that it waits 0.1 seconds before calling the function. And now we got this in fade embers, but now I'm going to copy this, and we also need to put it at the end of darken decal. And we need to do it here too, because that's what starts the whole chain of events. But we don't want to call it unless it actually needs to be called, meaning there are embers. So we only need it after the flammable true path here. We don't need anything after the false. So now let's test this out. Let's see how long it takes our embers to fade. Compile and save. All right, 2. Grass darkens pretty quick. It's exactly what you'd expect for grass. And the embers are ramping up. We see our opacity values printing there on the left-hand side. Yep. And as they're darkening, let's see how quickly they get to 0.7, which is where we clamped them. And the embers are going to take a little while to actually fade, but I think that's realistic, right? But it's not realistic in one way, which is we want the flammability of any given material to be based on what that physical material actually is, right? So grass should light a lot quicker, a lot faster than, say, wood. So that's the last thing that we're going to set up. So based on physical material, we're going to set up how quickly that opacity increases with time, as well as the flammability. And you see right about there, it took about 45 seconds. And yep, so now those embers have faded. So now on the Fire Decal BP, we're going to set up a new variable. And this variable I'm going to title burnability. And it's going to be a float. And I'm going to make it instance editable and exposed on spawn. And also down here, the slider range, we're going to make this between 0 and 100. And same thing for the value range, between 0 and 100. So now in our darken decals function, I'm going to move over all the way to the beginning here. I'm going to create some space. So here's how this is going to work. So based on the physical material that's being hit, it's going to set a value of burnability. So let's say for wood, the burnability is 20. So we're going to get a random float in a range, and then I'll drag in a reference to burnability. And let's say in that wood example, so burnability is 20. So if burnability is greater than whatever this is, then it'll do the rest of the function. So this is a way of basically decreasing the effect of everything in the darken decal function, or decreasing the probability that it'll be executed in any given tick, in any given collision event. So you could think of this as like, if you have a pile of leaves, that's going to instantly ignite, right? So in that case, burnability is going to be 100. It's always going to do this. But like a wood log, probably burnability of 20. So it's only having 1/5 the effect. It's only going to darken, and the embers are only going to occur at about 1/5, like 20% as quickly. So I'll say burnability if it's greater than whatever this random float in range is. And then we'll branch this, and we'll connect this up. And then only if this is true will this entire string of events occur. So if something's 0, like if burnability is 0, like this will never occur. And that's an easy way then to make a certain material completely immune to these decals so that the burnable effect will never occur. So let's compile and save. Last piece of this. Let's go back to our game playability fire. So now we have to set the burnability for each individual physical surface. But to make this a lot easier and basically take care of 2 problems at once, here's what I want to do. I want to collapse all of this. So all of this stuff here, I'm going to highlight all of that. Not this function down here, but all of this stuff. I'm going to right click and collapse to function. Move that up here. So that's a lot simpler already. And this function is simply going to be, if we right click, rename, this is going to be our Fire Decal Update. And I'll go into that and I'll move this up here. And the reason I created the function now is because in this function, we're going to create 2 local variables. We're going to create whether or not the material is burnable, and then also its flammability, that 0 to 100 value. And that's going to be set in each of these paths right here. I wanted to set them as local variables and not overall variables on the gameplay ability fire, because really we only need them for a moment to help spawn the fire decals, and then we don't need them anymore. So I'm going to drag these out, make some space, and we'll create the variables. So under local, this is going to be local flammable, question mark. And the next one is going to be local flammability. No question mark for that one, because that's going to be a number, float. I don't know if I explicitly said this before, but local variables, they are only used within that function. They are not saved outside of that one path within the function. That's exactly why we're doing that here. And now I can delete out our spawn actor Fire Decal BP here, because every single one of these is going to run through this one right there. And I can move these up over here. I'm going to drag in a reference to our local flammable. This is going to be set, and then local flammability also set. And now for our default execution pin here. So this is our default physical material. So this is where the physical material is not actually set. I'm going to say local flammable set to false because I don't want it to be a flammable material by default. And then the flammability here, I'll set it to 50. So basically 50% of the time, that's when it'll execute everything in the darken decal function. And then if I move this out a little bit, so right here, this is where I'm going to connect a get local flammable to there. And then local flammability, I'm going to do the same get right here. Actually, I just realized I named this wrong. So we'll right click, rename, we'll title it local burnability. And you see it automatically adjusts the names here. Okay, so let's connect this up to default. Connect this up here. And I'm just going to disconnect these other pins. And then I can just duplicate this about 6 times. And I can copy both of those. There we go. I think I need just a few more. So one more set of duplication. Right about there. Connect up here, connect up there, connect up there. And also connect them up on the other side. And then what I'll do from an aesthetic standpoint, move these down here, reroute this one also below. Now if I want to be really clever, I could set all these to local variables too, and then just connect them up right there. So now I got to figure out which of these is flammable and what I want to set the threshold to. So remember, the burnability, if it's low, it's not going to burn that quickly. And if it's high, it's going to burn very quickly. So the grass is flammable. Forest floor, flammable. Wood is flammable. Everything else, not flammable. Maybe if I want to, I could set the dirt to be flammable too. So yeah, why not? Let's make that ember. Forest floor, I'm going to keep at 50. And then grass, I'm going to make this 80. So it burns 4 out of 5 hits. Dirt, I'm going to reduce this to 30. Stone, I'll reduce this even more to 20. Wet dirt, also 20. And wood, 40. And water, don't want it burning at all, so 0. Compile and save. The last thing I'm going to do in our Fire Decal BP under Fade Embers here, I'm just going to get rid of our print because I don't want to print the opacity every single tick. And there we go. And so now let's start out a series of tests. So grass, so it still burns pretty quickly. Let's see how quickly the embers, yep. See them embering. And so now rocks. Yeah, so rocks are darkening very slowly there, right? They are darkening and no ember effect. The other thing we can do in the flamethrower effect itself, when it gets spawned, I'm going to decrease the intensity down to 20. And I'm just going to take a look, see what kind of impact that has. Move this back over to grass. Alright, so much less intense flamethrower. It still darkens pretty quickly, which you'd expect. I mean, it is a flamethrower. But I don't see the embers. Now I see the embers. So the embers occur much more slowly with that weaker flamethrower. So that concludes our episode for today. And in our next episode, we're doing our 3rd gameplay ability. Spellcasting fireballs while being able to move around and aim. All in one episode. So I hope to see you there.